Good evening. Welcome to the QCIS channel. On this channel, you get a daily dose of science, technology, engineering, and math. My name is Leon Jones, and tonight I'm going to get into something that's more or less on a project management side, and I'm going to talk about commissioning. What is commissioning in construction? What is commissioning in construction? Now, when something is out of commission, I'm going to take the opposite of something that's commissioned already. That means it's not working. It's not optimal. It's not safe. But when something is commissioned, it's optimized. It's safe. So when we commission something in construction, that means we turn it over to the owner. Case in point, when I go out there for a state DOT or a federal government agency, and I'm contracted to build a building, well, the building or the road that the contractor is putting together is the contractor's responsibility. Now, once the building and the road is completed, and the original owner, the contractor, and of course the owner's representatives, which are the inspectors, the RPR, the project supervisor, they do a final walkthrough and they create a punch list. Well, here's what happens after that. If there are deficiencies during that final walkthrough or that final inspection, they're all going to be documented. They'll be given to the contractor so he can correct those deficiencies. Now, after the deficiencies have been corrected, they'll do another walkthrough to make sure they have. Now, at this point, the contractor is still responsible for the building or the road. Now, everything is completed properly to the satisfaction of the owner. Then the facility gets turned over to the owner. And when it's turned over to the owner, that's commissioning. Let's get a little bit of read on commissioning. All right, what is commissioning? Okay. Commissioning is what we utilize during the last phase of a construction project. We call that the commissioning phase. That's where the subsystems are integrated together to form the desired plant process and tested as a system to verify project specification requirements are met. Now, the term commissioning refers to the activities from the point in the project when construction is complete or equipment is installed, till the equipment is placed in the service and handed over to the owner's operation team. We say operations team for continued operation and maintenance. Now, during this article that I'm presenting to you, I'm going to explain to you the commissioning phase of a project and the details of activities to place a new or upgraded industrial plant in service. So I'm utilizing a plan, and we're going to go in phases so you'll understand how the commissioning process works. Now, planning during construction and design. Planning during construction and design. Now, there are a few activities that take place off-site prior to the commissioning team mobilizing to site during the design and construction phases of a project. Now, during design and construction, the schedule and sequence of activities during commissioning, they're used to define the required construction milestones in order to plan the project schedule. Now, the construction milestones then define the required design milestones. So from the sequence of milestones, the project team is then aware of what activities are needed to complete the project, or the activities that need to be complete, and by when to ensure all of the project components come together as a final system for testing. And after that, the commissioning team is defined during the design construction phase to determine the core members of the commissioning team, as well as the support resources required from elsewhere on the project. Now, an important group to ensure that are basically part of the commissioning team is the owner's operations team, as commissioning activities are the best opportunity for the ops team to learn about the systems and become familiar with the new operating requirements prior to taking over the systems. Now, other members of the commissioning team are the electrical, mechanical, automation, key discipline leads, consultant subject matter experts, which is known as SME, contractors, vendor reps, and owners reps. Roles and responsibilities of the commissioning members is one of the lessons that you're going to get in-depth training. And you can also find that in-depth training from the Commissioning Academy. Now, as always with inspections, commissioning is also documented. So, what I'm going to tell you right now is commissioning documentation is defined and prepared in advance of the commissioning phase. This includes the test plans and test procedures to be executed during commissioning, and you're going to require checklists as well as drawings. It is critical that the construction team deliver an accurate set of red line drawings to the commissioning team in order that the correct installation, or we can say installed configuration of equipment in the field, is accurately documented. Now, as construction is completed and equipment installation is complete, the construction and commissioning team will perform a walkthrough to identify any contract deviations or deficiencies. And it will list all items on a deficiency tracking list. I just explained that. That's the final walkthrough. And this is where you're going to basically create a punch list. Now, deficiencies are then classified as type A, type B, or type B, identifying when each must be complete. Now, type A is a showstopper and must be complete before proceeding to the next activity. However, type B does not need to be addressed immediately, and it does not impact subsequent activities, but must be rectified prior to handover to the owner. And then there's type C. Now, type C deficiencies are minor defects, and they're agreed by the owner to be rectified after handover to the owner. Now, contractor document deliverables are defined such as O&M manuals. Now, does anybody know what O&M stands for? If you don't, I'm going to tell you. You have Army Corps of Engineers. When I worked at DNR, we had O&M manuals. O&M stands for operations and maintenance manuals. Of course, you need training plans to be delivered during the commissioning phase as well. So basically, Any specialized test equipment or special tools are defined and procured prior to commissioning. So if the constructor is required to provide any specialized equipment, this is also defined. Now, methods to gather test results need to be determined either as data logging systems or manually recorded. Often there is a significant amount of information produced during commissioning and a plan to gather, analyze, and report on the test results, and they also need to be determined. Now, the stakeholders of the project will need to be informed on the commissioning process. It's going well and any issues that were encountered on the project. So what information needs to be conveyed and to who should be agreed to by all stakeholders. That's going to be accomplished prior to the start of the commissioning process. And last but not least, safety management systems need to be established prior to commencing any commissioning activities. Now, as we deal with energy, there are what you call energy isolation procedures, and they're known as lockout, tagout. We call that the LOTO process. That also needs to be established and points of contact identified as responsible for the process. Then we get to the FAT, factory acceptance testing. That's part of the procurement phase. Now, during the design and procurement phase of the project, a critical step prior to equipment delivery is factory acceptance testing, known as FAT. Now, FAT verifies that the equipment is designed per specification before leaving the factory, where any issues discovered are much easier and cheaper to fix rather than delaying testing equipment when it's installed on the site. Again, if you have a piece of equipment, you want to make sure that it is verified as per specification. And that's what FAT does, the factory acceptance testing. And the reason why you do that before leaving the factory, it's because the piece of equipment is going to be easier to fix. But if you have some problems when you take it off site, well, there's going to be delaying in testing until the equipment is installed on the site. So FAT can consist of hardware verification, such as dielectric testing of major equipment or panel wiring of any control cabinets. Again, FAT can consist of hardware verification, such as dielectric testing of major equipment or panel wiring of any control cabinets. FAT can also consist of integrated testing where automation or protection control logic is loaded into the hardware and verified for correct design and functionality. If this is specified in the contract, then this must be done before the equipment leaves the factory, because field devices and wiring do not exist in a factory bench testing, and in interfaces will also need to be simulated. So you have to make sure that everything is in the contract. And when I mean in the contract, it's specified in the contract before anything can be tested and simulated. So integrated FAT is the most thorough verification, and it reduces schedule risk in order that any errors are discovered prior to site testing. But this requires that the automation design be completed in advance. It is important during procurement that schedules be planned to allow sufficient time for this to take place as often as the panel wiring and field device designs are not completed. And of course, logic is difficult to complete without full hardware design. However, through FAT, which is factory acceptance testing, it will always make on-site commissioning go much better if it is known in advance that the hardware delivered to site already works with logical design. Then we deal with mechanical completion, and that occurs at the end of the project once equipment is installed. And why? Well, that's just the last item. It goes in sequences. And because everything goes in sequences when we deal with mechanical completion, there is often a formal handover process with forms required to be signed confirming that equipment is installed per the design. The construction team and commissioning team will perform a walkthrough to inspect the installation and confirm that there are no deficiencies. Deficiencies are noted and added to the deficiency list, which we call a punch list, with associated classification. Now, confirmation of basic installation is confirmed, such as valves installed in the corrective or in the correct direction. Again, confirmation of any basic installation will be confirmed. Any example is we're going to utilize valves that are installed in the correct direction, and all wiring point-to-point checks and megger tests have been completed. Now, P and ID drawings are traced in the field to ensure that air, oil, water auxiliaries are available. And the construction team will verify that drawings are marked up, red-green drawings to indicate the as installed condition, and mechanical completion is the point in time when the red line drawings are delivered to the commissioning team. Now, what are red line drawings? Now, we're dealing with a plant here. If you don't know what red line drawings are, I'm going to explain them to you. And you heard the word red and green. In construction, we call them as-builts. So what it is we take the original drawing prior to construction, and then when we add something new, we actually utilize CAD or sometimes hand draw it in red onto the plans to let you know that here's what was added to the original plans. Again, we call those as-built drawings. I'll do a video on as-built drawings as well. Now, at each mechanical completion, a deficiency list is generated and any type A deficiencies rectified before moving, they're rectified before moving into the pre-commissioning phase. Now, on-site commissioning, upon mechanical completion of each portion of work and deficiencies, they have been agreed to. And then once all that happens, and I'm talking about when we look alive at the mechanical completion for each portion of the work or each activity of the work, and then we see that all deficiencies have been agreed to, then the pre-commissioning activities can commence. Now, for mechanical systems, pre-commissioning activities consist of cleaning and flushing of pipes, pressure testing, and leak testing. Any rotating equipment such as a pump, they're bump tested, which means rotating for the first time on site to verify current, draw, pressure, and flow rates. There may be an initial running period of motors and pumps to verify vibration and heating, cooling, as well as to confirm no infant mortality issues. Now, for electrical systems, pre-commissioning activities consist of panel energization, communication checks, loop checks, whether internal and external, and verification of any wiring to the central room is also required. And again, when we deal with electricity, more detailed electrical checks of automation or control protection circuit may also be required to confirm that any minor updates since FAT, which is factory acceptance testing, are uploaded to equipment, and then that the correct protection settings are applied to protect devices. So basically, current injections are done on any current transformers to verify correct polarity calibration prior to applying primary power to major equipment. So basically, pre-commissioning checklists are completed for each piece of equipment and may be witnessed by consultant SME to verify tasks that are being completed. And as each equipment pre-commissioning is complete, new deficiencies are added to the deficiency list existing from factory acceptance testing or mechanical completion walkthrough, categorized all type A deficiencies rectified. And then we get to commissioning. So following completion of pre-commissioning checklist, commissioning can begin. Commissioning is the on-site process to verify that the equipment has not been damaged during the shipping since the factory acceptance testing was completed. All field devices are installed at this point, so field wiring is confirmed to be correct, and a subset of FAT tests are repeated to ensure the equipment can communicate to all field activities and that equipment is calibrated. And remember, mechanical commissioning consists of dry commissioning and wet commissioning. Dry commissioning confirms proper function of mechanical systems without process fluids, while wet commissioning adds the process fluids and chemicals to perform operation, such as you need fluid for a hydraulic machine to work. Now, moving on to electrical commissioning, that consists first of pre-energization safety. When equipment is first energized as a system, it may be that construction is still taking place next to the equipment under test, and it must be ensured that the power is safely isolated from any equipment installations. And that is very important, such as a circuit breaker, something with high voltage. It could have 480. Lockout, tag out. That's where that comes into play. If you still have equipment and it's supposed to be energized, but construction is still going on, just make sure lockout, tag out is in place. That's safety reasons. Make sure lockout, tag out is in place. And that's the isolation, because once isolations are confirmed, equipment racks are powered up and system integration can now occur. Now, the field devices are verified to be correctly rejected on HMI screens, and that control of field devices can be done from the central control location. End-to-end communications are verified as accurate and reliable. And once all mechanical and electric components are complete, again, once all mechanical and electrical components are complete, system commissioning can begin, where all the electrical mechanical equipment works together as a system for the first time. Now, auxiliary systems, again, that's auxiliary systems, they're brought online, followed by major apparatus and interfaces. They're also verified for all equipment. It is now that all the systems are available and ready for startup of the plant processes. Commissioning checklists are completed and witnessed by consultant SMEs. Similar to previous stages, the deficiency list is updated with any newly discovered deficiencies, and all type A deficiencies are rectified prior to moving to the next steps. And then we get into the process setup stage. And at this stage, the plant process can now be started. This could consist of power transmission system, biological nutrient removal system, or any other industrial plant manufacturing or specialized system. Mechanical processes are slowly started, and piping is configured for the initial operating scenarios. Flows are started and monitored to ensure correct operation. Electrical interfaces are verified and power is slowly ramped up to operating levels. Automation is executed and fault scenarios are tested and verified. The equipment undergoes analysis at each stage to ensure the plant process is operating as specified. The consultant SME and owner reps are present to verify correct operation of the plant process. The plant is now up and running and functioning as a system, ready for fine tuning to optimize the process. Then we move into performance verification. And any fine tuning of the plant process operation is conducted by the commissioning team with consultation with the consultant, SME, and with the owner. Once turned, the contract may require a trial period where the plant process is expected to operate uninterrupted for a period of time. Now, this could be 24 hours or even 30 days, for example, and that's dependent on the contract requirements. Now, should the system operation be interrupted, the trial period starts over. Once the trial period is completed successfully, then you have the PAC, which is the provisional acceptance certificate, is issued to the contractor. The contract may also specify a performance guarantee period where the plant processes are expected to meet certain contractual criteria over a period of time. A performance guarantee period may have commercial impacts depending on the performance that's been achieved. Now, once the performance guarantee period is complete and commercial impacts have been determined, then there's the final acceptance certificate known as the FAC, and then that is going to be issued to the contractor. And then we get into operation readiness or operational readiness. So as the project approaches the in-service date, it is beneficial to the owner to prepare the operations team for eventual handover and operation of the new systems. Now, in fact, it's best to have the owners, operations staff involved in the commissioning process, as this is a great time for them to learn about the new systems and ask the experts who are on site testing the systems any questions that they have. Now, the operations staff have a vested interest in the operation and maintenance of the systems and are often the best to manage any document management systems or setup of asset management systems. A soft handover approach is the best to prepare operators as opposed to waiting to the end of the project, passing a bunch of new information to operators and the project team that will eventually leave the site. And again, training is a key deliverable for the operating individuals to obtain from the project. And of course, you can go to any type of manual or course or have any training sessions or anything you need to know about the commissioning process. Now, the owner will typically have an established asset management system. If this is a first new system for the owner, an asset management system may be a new system being established. So the asset management system contains information on each asset, the hierarchy of installation, nameplate data for each, preventative maintenance requirements, and warranty information. Now, the warranty period may require more specific maintenance requirements in order to maintain warranty, and this needs to be implemented in the asset management system for future demonstration of compliance to maintenance requirements to the contract. Now, the asset management information is contained within a software package that generates work orders for required maintenance tasks and records of completed tasks. So the project team may be responsible to provide the information package containing all asset information to be loaded into the asset management system for continued use by the operating team. Now, the warranty period begins once each piece of equipment is placed in service or at issuance of PAC. That's the provisional acceptance certificate. And that's depending on the contract requirements. Warranty period typically lasts from PAC to FAC, which is the final acceptance certificate, and can be done 2 or 5 days depending on contract requirements. So some equipment may have extended warranty, such as battery systems, or others then extend longer than the project warranty duration. As I move on, when we deal with the warranty period, that's when any type C deficiencies are rectified by the contractor, as well as processes they're basically required for the owner to request any changes or service to the system. So as the contractor must be involved in any changes to the system, and the reason why they're involved with any changes to the system, that's to ensure that the warranty is not voided by any unknown changes. We get into process completion. So once you get the final acceptance certificate or the FAC, the project officially comes to close. Again, the project is only complete once the FAC is issued. The FAC is a final acceptance certificate. And again, once that's received, the project is officially closed. Now, if design, install, and commission goes well, the asset should last many years into the future. So, as you can see, there's a lot involved in commissioning and starting up an industrial plant. It can be a complex initiative, but it is the best part of the project as you get to see the original design come to life. So you have individuals who have been utilizing the commissioning method for 20 years. So I just wanted to share you some insight about what I know to give you some knowledge. And I'm not an expert on commissioning, because basically a lot of your commissioning is done with valves and electrical and mechanical equipment. However, you can do it with other types of construction, because with my presentation, I utilized an industrial plant because it has everything that you need for commissioning. Basically deals with parts, operations, and manuals. And the knowledge that you're going to get here, and I'm giving you the basic knowledge. If you're already in commissioning, this will help you thrive in your current career of commissioning. And basically, again, we've gone over FAT, which is the factory acceptance testing. Remember, there are 3 types of deficiencies. Type A, that's basically your major that must be rectified before anything goes any farther. Type B, you can delay it a little bit. And type C, everything is minor. Then we get into your certificates. We get into your provisional acceptance certificate, which is your PAC. and we get into your final acceptance certificate, which is your FAC. Now, basically, when we deal with O&M, that's basically what is involved in commissioning operations and maintenance. And I'm going to go back and deal with construction of a road. Once we put down new asphalt, guess what has to occur after that? Well, we know we're already going to put traffic on the road. And as time comes and goes, roads are going to age as well. So what's going to happen? They're going to need some maintenance. And really, the maintenance is the lifeblood of every operation. If you don't maintain your infrastructure, you're going to spend a lot of money. And this is why you have to track everything when it comes to maintenance. You even have to have a system of maintenance. You know, a number of individuals, we can go out and buy cars. I'll give you an example. And we wonder why our cars break down. And eventually they do break down. And for the most part, it is something mechanical. Now, if you want to keep your car running, what do you have to do? You have to make sure your fluids are changed, your brake pads are changed, and you have to test your car out as well. Just like if you utilize, as now they have all these emission standards. So this is when you have to go and get O2 sensors and valves. Well, in order for your car to actually pass the test, you have to drive it after you put the new valves in, because your car is going to fail. Now they want you to drive it at least 300 miles. Well, what you're doing, you're breaking the new parts in. You want to make sure that everything works properly. And you think about this with your car. You take your car to get a tune-up. You get some type of maintenance work, some new parts in it. Well, until you pay that bill, the shop is responsible for that car. But now, before you even pay that money, you want to make sure that everything that you ask to be fixed is fixed. Because if it's not, then you got to take it back. Although you might have a warranty on that part, it's going to cost you time and it could cost you money and gas. And the way the commissioning process works starts in phases. And the whole process of commissioning is for the contractor who was installed or built something to turn over the infrastructure upon completion of the punch list, because there's never been a project without a punch list. Remember, I just told you, you have 3 types of deficiencies here: type A, type B, type C. Want to make sure that the contractor and the owner agree to everything before the piece of equipment or the infrastructure is turned over to the owner. And that's basically what commissioning is. You're looking to turn over a project to the original owner. And everything gets commissioned, but it gets inspected, it gets tested, everything is documented. Because before you turn anything over to the original owner, you must make sure that the system is working correctly. And if you have to test a part at the factory, make sure you do that. Make sure it works well before you take it off site, because it's going to cost you more money when you take a product or a part that you believe worked while it was at the factory, when you could have fixed it there. Then you got to take that part and demold that part from the project site back to the factory. It's costly, That's why you have asset management. Keep records of everything. Make sure that you utilize your manuals, your operations and maintenance manuals. When it comes to projects, all specifications, all designs, they're important. Because if you understand what is in the contract, you understand the plans and specifications, you understand the inspection process, the testing process. Although commissioning is not easy, it is a process that will ensure that your facility will be safe, it'll be maintained properly, and you will add life to your project, and it will be in a cost-effective manner because projects do get old. But if you utilize the process while your product or project is at its young age, it's going to be much easier for you to keep that product or that part running properly as long as you maintain it. You add years to your infrastructure or your part, as long as you follow the examples of commissioning. And that concludes this topic on commissioning. If you like what I just presented, please comment, share, and subscribe. And if you're looking for some political content, I'm working on a scam series right now and some social content, you can check out my main channel, a 411 Talk Zone radio show channel on YouTube as well. Now, once I record all of my videos on the 411 Talk Zone radio show and the QCIS channel, I upload those videos to my Twitter page, which is X. Now, since the QCIS channel is an educational channel, I will post that information to my LinkedIn page. The information that I presented tonight, that will be linked at the bottom of my video description. And once again, thank you for viewing this topic on commissioning or construction from the QCIS channel. On this channel, you get a daily dose of science, technology, engineering, and math. Till next time, my name is Leon Jones. I want you all to have a wonderful and gracious evening.